Assalamu alaikum. I'm Vivian. I'll be explaining the last part of chapter 5, strong acid and strong bases. There is one objective to be covered in this part. The objective is to recognize what happens during an acid-base titration at the molecular level. Actually, you know well what happens during titration, but in this PowerPoint or in this video, we have to explain in details, as we said, at the molecular level. For this reason, let's consider this example, the titration of a sodium hydroxide solution NaOH by a hydrochloric acid solution HCl. So definitely the HCl solution here will be in the burette, and when I say HCl, it means the species present will be H3O plus and Cl minus, and in the beaker we have NaOH solution, it means Na plus ions and OH minus ion. Now, look, this is the burette, and these are the chemical species present in the burette. We have here in a schematic way represented as much as we can H3O plus ions and Cl minus, because we said that we have here what? HCl. So HCl is dissociated in water and it's present in that way. And here in the beaker we have NaOH solution. It means we have Na plus ions and OH minus ions. Now what happens during titration? During titration, first of all, let's consider this time, before equivalence. Why before equivalence? Because we didn't add any drop of HCl anymore. So we simply are at the initial time where just NaOH is present in the beaker. So this is before equivalence. What are the species present in the beaker before equivalence? Pay attention that here we are dealing in the chemical species in the beaker. We have, as you can see, Na plus, we have HO minus definitely, and we have the solvent, that is H2O. Okay? Now, upon titration, let's open the tap to allow a drop of HCl solution to come in the beaker. Look, slowly. Look, imagine this is the first drop. I would repeat it again. Can you see this H3O plus and Cl minus? Now they are in the beaker. Now, definitely it's very rapid what happens in the beaker, but imagine slowly what is happening. This H3O plus and Cl minus are now in the beaker. What will happen? Look, this H3O plus will react with OH minus. How do they react together? Look, according to this reaction, which is the titration reaction, so this H3O plus OH minus, as you can see here, will react together to produce what? 2H2O, that is liquid, that is the solvent. So what happens actually here? Can you see there is no more the H3O plus that comes down from the burette, and there is no more OH minus. They reacted together producing two water molecule, which is a solvent. Okay? Now, look at Cl minus, it's a spectator ion, so although it has been added from the burette, it's found here and it doesn't have anything to do in the beaker unless it will combine to Na plus present here. So this is why these two ions are a spectator ion. This is why, look what I added here. So before equivalence, we have Na plus OH minus, as we said, because we still have this, because we are before equivalence. We have definitely the solvent. We have H2O that has been produced here, but even I wrote here the word product, it doesn't mean anything, because this H2O will be added to the water, which is the solvent, and we can say simply we have solvent water, not necessary to distinguish between the product and the solvent. And what do we have other? We have Cl minus. Okay, so before equivalence, I repeat, we have the two spectator ions, one coming from the base, the one coming from the acid, the OH minus coming from the base that is in the beaker, and we have H2O. Now, let's repeat, or let's continue titration, because titration didn't finish so far. Here is another drop, let's say, of HCl that will be added in the beaker. Again, look, this molecule, or these two ions that are now in the beaker, what will happen? Again, this H3O plus will meet one OH minus present already in the beaker, and they will react together again according to the titration equation, producing 2H2O. So look here, focus here now. let's say, voila, there is no more H3O plus, there is no more OH minus, we have simply H2O. About the chemical species present, we are always before equivalent because we still have the same chemical species, because we still have OH minus, so we didn't reach equivalence. Again, let's continue our titration by adding an extra drop. And again, look at this H3O plus Cl minus. What will happen now? The same phenomenon would be repeated. Look, this H3O plus and OH minus will react again according to the titration equation, producing H2O, and one Cl minus, which is a spectator ion, is added. Now, as long as we have OH minus in the beaker, this means that we are before equivalence. So let's add again another drop, okay, of HCl, and again what will happen? This H3O plus will react with the remaining OH minus, producing H2O, and Cl minus is added. Now here we reached equivalence. Why? Because look in the beaker. Are there any more OH minus ions? No. All OH minus ions reacted with the H3O plus that were added from the burette. So at equivalence, pay attention, we have those chemical species. The Na plus, which is a spectator ion coming from the base, the Cl minus, which is a spectator ion coming from the acid, and water, which is a solvent. And as I can see, you don't have to do this distinguish. So in exercises, when you will be asked about the equivalence, about the species present, you have to list three: the Na plus, which is a spectator, the Cl minus, which is a spectator, and H2O. Now, you know that in titration we will continue to draw the curve. So let's continue adding a drop, let's say, of HCl. Look, now when this H3O plus here is in the beaker, it didn't find any more OH minus to react with. So what will happen? It will stay. Okay, and this Cl minus also will stay again. Upon adding, so after equivalence, look, there is a chemical species that is added to the beaker, which is the H3O plus, which didn't find, as we said, OH minus to react with, so it will still here in the beaker. Again, we can continue our titration to draw our curve, as you know. Again, what will happen? Simply I'm adding H3O plus and Cl minus that don't react with anything because there is no more OH minus. So after equivalence, as I said, these are the chemical species present, the same as equivalence, but I will add to it the H3O plus coming from the burette. Now, as long as I add the same phenomenon. Okay? Now here is a table that shows the quantity of the species in the beaker, I repeat, in the beaker at the different moments of titration. Here the numbers in the beaker, as I mentioned here, are arbitrary. It means definitely they are not real, but just it's an idea to understand. In the initial state, what do I have in the beaker? I have simply the base. I have no H3O plus, no Cl minus, because I didn't open the tap of the burette. And definitely the water is always in excess, it's a solvent. So we don't have to mention either that it's in excess, we said the solvent. Before equivalence, I have added HCl, I have added, it means H3O plus and 2 and Cl minus. But what happens to H3O plus added? They react with OH minus present in the beaker. But before equivalence, we have OH minus greater than H3O plus. So as you have seen in the previous slide, H3O plus reacts with OH minus, and some OH minus will still at before equivalence. And definitely the spectator ion, nothing will change in their number. And here we have a new spectator ion in the beaker, which is Cl minus coming from the HCl added. At equivalence, akid, at equivalence, we don't have any more HO minus because this is equivalence, it's a neutrality. We don't have H3O plus, simply we have Na plus and Cl minus with equal numbers, and definitely we have H2O. Now after equivalence, this one, there is no more OH minus. This is 4 Na plus. Actually, it has to be 7, this one. No, sorry, it's 4. Excuse me, it's 4. And here it's H3O plus that is added. Now why 3? Because simply I have chosen 3. I might write 2, I might write 4, I don't care. So this is just the amount of H3O plus added from the burette, and here is 7, and definitely we have water. So in this PowerPoint, we try to show you what is happening in titration at molecular level. Now, this is your agenda. You have to pay attention to memorize the chemical species present before equivalence, at equivalence, and after equivalence. You have to write the chemical equation of titration that you know it well, and you have to write the equation of the reaction taking place at equivalence. Thanks for your watching. Thank you.